In this video, we are going to discuss about the turbines principle and operation of Pelton wheel turbine. In the previous video, we have seen what is a turbine and what are the classification of turbines. So the classification based upon the pressure head and the axis, the flow of reaction water. Like that, we have seen the classification. And now, one of these turbine is a Pelton wheel turbine, which is a tangential flow turbine. So how it is working, what is the principle, working principle and all the parts and everything we are going to see in this video, right? So this Pelton wheel turbine is based on the classification. As we said, it is a impulse turbine. Okay, it gives the impulse turbine. Now we are going to see about the Pelton wheel turbine, how it is there. So this is, it consists of buckets. It's circumference on that shaft. Everything is the periphery, on the periphery of the shaft, the buckets, we call it as a buckets, and they are a runner bucket. So it is arranged in a manner that when water is going to hit on that, it is going to be rotated. That is what here. So it's a type of a tangential flow and impulse turbine. Impulse in the turbine, in the sense the water directly hit on the blades and it is going to be rotated. The energy available at the inlet of the Pelton is a kinetic energy. The kinetic energy of the water, when the water is flowing through the penstock from the dam, the reservoir, a pipe is connected and it is connected to the Pelton wheel. So when the water flows, it hits on the turbine blades, which is the buckets what we have seen in the last previous image. So here the flow of water is going to be taking place, and that it hits on the turbine as a that's what tangentially impact on it. So the pressure of the inlet is atmospheric pressure, and this turbine is used for the high head turbine. Now we can see this the construction of the turbine, how it is going to be function. So there is a penstock, we call it as a penstock, where the water flows from the dam. The water flows through the penstock, and at the end of the penstock we are having a nozzle. So the nozzle directs the water over the blade, that is a runner blades. So we can see the buckets or vents which is arranged in the periphery of this shaft. So that we call it as a runner is going to be rotated when water hits on the buckets. So this bucket are going to get the kinetic energy of the water, and it starts to rotate. So when it starts to rotate, the runner is rotating and the shaft is going to be rotated. All the parts are covered with the casing. Casing is the one where it is helpful for avoiding the splash of water. So here in this case we can see one by one this, what is that arrangements, what are the parts in that. So in this Pelton wheel, first we need the nozzle and flow regulating arrangement. So through the nozzle, when water comes through the penstock from the dam reservoir, so that water should hit on the turbine blades. So there we are using a nozzle, the nozzle having a spear. So the spear is used to control the water, that is regulate the flow of water. The quantity of water which is strike on the buckets, we call it as the buckets on the periphery, whatever it is there, the runner, we call it as buckets. So the water will hit on the buckets through the nozzle. So the spear is used to control the flow of water. So the nozzle is used to increase the kinetic energy of the water, and it is going to strike on the buckets of the water, so that it can it converts the kinetic energy of water into a rotary energy of this motor shaft. So that the nozzle arrangements, the conical needle present in the nozzle, it can be operated by a hand wheel at the back. When we are rotating the hand wheel, the spear will move forward and backward, and so that the flow of water can be controlled, and it can be increased or decreased for pushing the forward of the motion of the water towards the blades. And the runners and the buckets, or next part, where the water is going to be get. So runner is a rotating part. Okay, so the periphery, as I said, the buckets are arranged in a evenly spaced manner, and the buckets have two hemispherical ball joined together. That's called there is a center hemispherical called a splitter. So that splits. There is a wall between the two hemispherical balls. So the water will hit on the jet of water through the penstock and through the nozzle, which hits on the center of this bucket, so that it gets the energy of the water and it is going to be rotated. So the buckets are made up of cast iron to withstand for the high pressure and high vibrations now. And the casing is the one which covers all the parts of the turbine, the buckets and all. So it is outer covering of the turbines, so we call it as a casing. It is made up of cast iron. So it is used to normally fabricated steel plates, and it make a safeguard, okay, like for preventing from any accidents, because the runner is going to be rotated very high fastly, and it avoids the splashing of water outside. So it covers entirely the areas where it will avoid the splashing of water, and it will help for the discharging of the flow through the tail race, right? So next, braking jet is the one which is opposite side. When water, if you want to stop it immediately, so that it will hit on the direction. When the jet of water completely closed, then the runner becomes, it will be rotating. The runner will be rotating because of the inertia. So continuously it will be rotating. To avoid to stop immediately, then we can make a braking jet that is in the opposite direction of the backside of the vents, that is opposite direction of the jet. The front side, it will, when it hits, the runner is going to be rotated. When we want to stop it, we have to set the braking jet at the backside of the vents, so that it will stop immediately the runner after stopping this nozzle there. So the working, as I said, we need water stored which is in the high head dams or passed through the penstock, and through the nozzle it will be hitting on the blades. So bucket, when the nozzle is used to increase the kinetic energy of water, so that it makes the runner to rotate in a faster manner. So when the buckets rotate, the shaft is going to be rotated. Mainly the turbine function is to convert the kinetic energy of the water into a mechanical energy, that is the rotation. Okay, fine. This is how this is going to be rotated. So application, it is used in high head turbine, that is 150 to 2000 meter height, and it is used to drive the generator which is attached to the turbine. So main concept of the turbine is to convert the water energy of the water into a rotary energy, and that rotary energy shaft is connected to the generator, where the generator is going to be produce the electricity, right? So in the next video, we will see about the Francis turbine. What is a Francis turbine? What is the difference between Pelton and Francis, right?